Hi everybody and welcome to this tutorial. In this episode we're going to be looking at transform. Transform is the thing that controls a game object's position, its rotation and its scale within 3D space. We'll be looking at that global and local level. So let's get started. I've got a Unity project set up here. I've just created a simple scene ready for us to start adjusting some transforms. I've just got a cube here and it's set at the minute to 0, 0, 0. So one important thing to understand is the global space positioning. Anything that is positioned at 0, 0, 0 is essentially at the center of the world space. So let's look at what we can manipulate with a transform. So we can manipulate a game object's position, we can adjust its rotation, and we can adjust its scale. And to do that, we've got a number of ways that we can do it. It's important to understand that we are working in 3D space here. So we've got three axes. We've got an X, a Y, and a Z. X will control the horizontal position, Z will control the depth, and Y will control the vertical position. And adjustment of any of these numbers will help position an object somewhere in 3D space. So to adjust the position, we can type in the position here. Let's do something where it stays on screen. And in a global positioning sense, if we look at this cube, it's at this sort of highest level within our hierarchy. So the positioning is using the global position. Now, one unit or one in any of these boxes represents one unit in Unity space, and one unit represents 1 meter. That's useful for VR development because we know that if this cube is scaled to 1, 1, 1, that it's a 1 meter cube, and if we position it 1 meter in front of the world space, then this would appear like a 1 meter size cube 1 meter in the distance. So that's really useful for us to be able to position objects. Let's have a quick look at how we manipulate these. So if we look up here, you've got a number of options. You've got your move tool, we've got a rotate tool, and we've got a scale tool. Now each of those will manipulate one aspect of this transform. So if we want to move this object in space, we can select the move tool, and you'll see we've got these axes and they highlight yellow based on the one that you've got selected. So if we want to move this on the x-axis, we can just click, drag and drop this, and we can move it into whatever position we want. So let's say we want to place it in this sort of bottom corner. We can use them to do that. Next thing is our rotate tool, and you'll see you've got these options now. So hovering over any of these will again highlight them yellow, and you can click and drag and adjust the rotation of these objects, and you'll see the rotation numbers changing up here as you're moving these objects. So you can also type them in here. So if you want to move this 45 degrees, you can just type 45. So the rotation, while I'm saying that, works on degrees. So 360 degrees would rotate that cube completely around, and you'll see that it can go above 360. So we could set this to 370, and that is essentially just 10 degrees rotated around the x-axis. But that's useful for when we're doing an animation. We may want to tell it to spin it 640 degrees, and it would just rotate around constantly until this number hits 640. So it's useful to be able to go above 360, and we can also go minus, which will spin it the other way. So you can adjust these rotations through these bars, or you can adjust them by typing them in. Or the other thing you saw me do there is if you just hover over the X or the Y, you'll see the two little arrow indicators come up, and you can click and drag that to adjust the rotation. So that's actually quite useful for placing something and quickly adjusting the rotation. If we jump into this tool, this is our scale tool. And again, we've got selectors here, so we can select to scale on our x-axis, on our z-axis, on our y-axis, and if we want to scale all of them uniformly, we can click the center and we can scale up with the center as well. And the same with these, you can adjust these scales through here. The other tool you've got is the move, rotate and scale the selected object tool, and that will give you the option of adjusting all of those things within one tool, so you don't have to select individual tools. You can select these and you can do it from there. I tend to not use this tool too much because I use the shortcuts, and the shortcuts are W for the transform, E for the rotation and R for the scale, and they're right next to each other on the keyboard, so you're able to quickly switch through each one and get the tool that you want, so you can quickly manipulate objects in space and get them to be positioned exactly where you want. I'm just going to delete that and create a new cube in the center, and let's give it our red material. And so now we can look at what is global positioning and what is local positioning. So if we look at this cube, it's at the top of our hierarchy, and its global position is 0, 0, 0. Its global scale is 1, 1 and 1. If we add another cube to this object and we just move this over here, the position, rotation and scale of this object is now going to be relative or local to its parent object. So if we start to manipulate the transform of this parent object, you'll notice that the transform of the child object moves with it at the same time. But if we, so let's move this to 3 on the x-axis, but we look at the position of our cube on the x-axis, this position is still set to 0, and that's because it's relative to this object. Now this becomes reasonably difficult to understand, and it definitely sort of threw me a few times when I first started, particularly if you're accessing these positions through code, because you suddenly think, right, I want to move this to be 1 meter to the left of or the right of the world space. So you adjust this to be 1, and it's not actually 1 meter in the world space, it's 1 meter relative to the parent object. Now that is how you would want it to be, because let's say you were building a person, you would want a body with arms and hands, and you would want the whole person to move when you move the body because the arms are attached to the body, and you would want the hands to move when you rotate the arms because the hands are attached to the arms. So it is how you would want it to do. Want it to work, but it becomes a difficult concept to understand, like I say, particularly when you're accessing that position through scripts. So this is just one of those things that you need to practice, and you need to understand that these objects are scaled and positioned relative to their parent object. So if we were to scale this object down and look at our cube here, our child cube is still at a scale of 1, 1, 1, and the parent object is 0.1. So we can still work within this parent object at the 1 unit scale. So if we want to create another cube, but we want to position it right next to this one, we can just move it 1 meter. Sorry, this one's already 1 meter, so we need to move this 2 meters, and that will move it 1 more unit to the side. And I've just said meters there, but then it's also important now to realize that 1 no longer equals 1 meter, it equals 1 unit relative to the parent object. So I hope that makes sense. So the parent object now is scaled to 0.1, which is 10 centimeters. So 1 unit on any child objects now represents 10 centimeters, and that steps down then. So if we again scale this to 0.1, 0.1 and 0.1, this cube is now 1 centimeter. So if we create a new cube under here, the scale is 1 when 1 is relative to this parent object, which is relative to this parent object. So suddenly in here a scale of 1 now equals 1 centimetre, and that's okay when we're working with ones. It's quite simple calculations to do, but if we were to scale this to any sort of random number, 0.371, you're suddenly not able to understand what this scale represents. So you're no longer able to understand what 1 actually means, but you, as long as you work in units and understand that it's taking its parent transform information, you'll be fine with that. And working at 1, particularly when you're importing objects from a package such as Blender, if you can export the item scaled correctly to a scale of 111 and it appears to be the right size, there's some optimizations Unity can do on there. So you want to try keep imported objects to a scale of 1 as opposed to some sort of weird scale, just due to those increased optimizations that you can get. And there's also some other things that don't scale well with non-uniform scale. So if we look at our cube here, it's currently got what we would call a uniform scale. So the X, the Y and the Z are all the same scale, so that makes this uniform. So I'm just going to take this to 1 and let's create a sphere, and we'll use this as an example of something that doesn't scale well non-uniformly. So if we look at our collider here, that's this green lines, you can see that that is a circle. But if we scale this only on one axis, we've now got a scale of 1 and 0.20233 and 1. So this is now a non-uniform scale object. But the sphere collider can't work with non-uniform scale, so you suddenly get a mesh that does adjust to non-uniform scale, but the sphere collider doesn't adjust to non-uniform scale, so this wouldn't collide properly. So that's another thing to be aware of. And there's a number of those objects, something like a capsule collider, the ends don't like to be scaled vertically and horizontally. So that's it for transform. With that information, you should be a bit more aware of how to position something in space and understand the parent and child relationship for those scales. It definitely threw me when I first started working in Unity, sort of understanding the scale side of things and the fact that it was relative to its parent object. It fixed a lot of issues understanding that. So thank you for joining me on this video, and I will see you next time.